Cable service companies also typically use an NID box such as this. It's used to contain a grounding block and splitters or filters depending on the service to the house. Or they may just supply a grounding block such as this that acts as the service demarcation point.
As we mentioned earlier, all of the outside services terminate in the distribution device. Its primary function is to support the voice, data, broadband RF, and AV applications. To do this, it has three primary functions. First, it terminates the outside services. Second, it provides all of the equipment necessary to support the in-home network, such as amplification, cross-connect, network hubs, and so on. And third, it provides a very flexible means to interconnect the outside services to specific network in-home outlets and products.
Per TIA 570A, cable runs will be home run from the distribution device to each outlet jack. That means that each jack has a dedicated cable back to the distribution device. Older style wiring, where outlets were wired together on the same cable, called daisy chaining, is no longer used.
Now, the standard also defines the minimum number and type of cables and outlets in two grades of service. Grade 1 is a minimum requirement to support traditional analog applications and services. Grade 2 is intended to support multimedia applications. Now, these include data network support as well as distributing in-home generated video sources. Now, the standard also states that each branch cable not exceed 90 meters or 295 feet. This is to allow them to be used for data applications as well as traditional analog applications. And then equipment cords not exceed 10 meters or 32 feet. This gives a total length of 100 meters or 327 feet from attached devices to the distribution equipment connection. We'll be referring to applicable parts of TIA 570 throughout this course. Now we're going to be installing the cable and hardware to support voice service throughout the house, data networks to support a wide range of network products as well as broadband internet access, and RF networks to support the traditional cable, off-air, and satellite service. Now let's start with an overview of the traditional voice service network. The traditional voice network starts at the telephone company's central office. Each telephone line uses a pair of wires from the office to the network interface device at the house. A pair of wires for each line then runs to the structured media center. Now, the media center allows each incoming line to connect to multiple branch cables to individual telephone outlets. Each branch cable contains 4 pair of wires to support 4 voice lines.
Connecting incoming voice lines to outlet cable runs is typically done with a voice line distribution module. This channel vision module is a good example. The voice service cable from the telephone NID is terminated in an 8-pin modular plug and connected to the input jack. This becomes the auxiliary disconnect required by TIA 570A. The 4 possible incoming voice lines are applied in parallel to the 8 110 style punch-down connectors along the bottom. The cables to each voice jack are attached to these connectors. If more than 8 voice outlets are needed, additional modules can be added as necessary by using a jumper cable from the output jack or punch-down connector. There is also a jack on the module to allow connection to a security system. When the line 1 switch is in the up position, line 1 is routed through a 4-pair cable to the RJ31 jack on the security system. This allows the security system auto dialer to seize line 1. This channel vision module provides a similar function. Voice service from the telephone NID is terminated in an 8-pin modular plug and connected to the top jack. This becomes the auxiliary disconnect. The 4 voice lines are connected in parallel to the 8 modular jacks. Cables to each voice outlet are terminated in modular plugs and plugged into any output jack. This allows easy disconnection and testing of each cable run. Expansion is easily accommodated by jumpering to additional modules. This module also has a jack and associated switch to allow connection to a security system. The module can also be used to distribute the incoming lines to other modules to support up to 64 voice lines. In larger homes, especially with home offices, residential phone systems are becoming increasingly popular. To interface with the connections to and from these systems, Channel Vision makes a KSU interface module. KSU is the generic acronym for the system controller. The incoming voice lines are connected directly to this module through either the modular or punch-down connectors. Up to 8 voice lines can be supported. A 25-pair interface cable is used to provide connection to and from the KSU control unit for support of up to 10 phone stations. Cables from the handset jack locations are terminated on the punch-down connectors. Now this module also has a jack and associated switch to allow line 1 connection to a security system. And there's also connectors for the door intercom units supported by most residential phone systems. Telephone lines, like all services that enter the house, must be protected from overvoltage conditions. Protection is provided by primary and secondary systems. Primary systems are required and consist of lightning protection and the grounding electrode system of the house. Phone line primary protection is provided in the network interface device on the outside of the house. Secondary systems consist of overvoltage and surge protection circuits built into the equipment that the cable attaches to. A good example is this Channel Vision surge protection module. It provides secondary overvoltage protection on 4 incoming voice lines and is connected between the NID and the voice distribution module in the distribution center.
Homeowners now have the option of getting voice service from their cable television provider as well as their broadband internet connection using voice over IP technology. We're going to cover how to implement those options a little later in the course. But now I want to enlist the aid of Dan Gregory, famous from our Do-It-Yourself DVD series, to help cover the characteristics of UTP cable in a little more